Hello everyone, my name is Strmečki. I'm a software developer and a PhD student at Faculty of Organization, Informatics and Management. Today we're going to talk about generative programming, especially AspectJ and GUI form generators that we developed in Evolution framework. In the first part of the presentation we're going to give you some theoretical background on generative programming, and in the second part we're going to talk about aspect-oriented programming, especially AspectJ AOP implementation in Java. The third part of the presentation will be about the design of our form generators, and at the end we'll make a quick demonstration. We start with some theory on generative programming. Well, the goal for generative programming is to build generative models for software families and to generate concrete systems for those models. The generative programming relies on a few other disciplines, most of all domain engineering and software product lines. In domain engineering, the main goal is to develop a common architecture for a software family and to devise a production plan for its members. Software product line tries to make use of common features that we find in software, and of course it tries to increase the productivity and reduce the development time, etc. In generative programming, it's highly recommended to use feature modeling. That is, in addition to our commonly used UML models, class diagrams, use cases, etc. So what's feature modeling? It is the creative activity of modeling common and variable properties, and of course their independencies. What's a feature? Well, in domain engineering, definition of a feature is it is a reusable and configurable requirement. Here is an example of a textbook feature model. So a feature model consists of a feature diagram plus some additional information. So in this example you see a car, and you see it has two mandatory features, transmission and horsepower. Transmission has two alternate features. It can either be manual or automatic. And here is one example of an optional feature, air conditioning. Here is some meta information that air conditioning requires some sort of horsepower. So this is really a textbook example, but you can apply it to any kind of software product. Now we're going to talk a little bit about generic and generative programming. Those are two terms that are similar but most certainly not synonyms. So generic programming has a few definitions, and it is used in a little bit of different ways in today's literature. But the most common definition for generic programming is programming with generic parameters. In generative programming, the word generative from the English dictionary means to have the ability to originate, create, or produce. So the basic difference is that generative programming includes the process of creating concrete instances. One other difference is that generic programming is focused on parameterization, and the generative programming deploys metaprogramming. We're going to talk about metaprogramming in the following slides. Here is one basic example of generic programming. We have a method that prints an array, has a generic parameter, and you send it an integer array or a count array, so it will work with any kind of parameter. The goal, of course, here is to avoid code duplication, and the origin of generic parameters is from standard template library of C++. Metaprogramming can be defined as the development of programs that are designed to read, generate, analyze, or transform other programs or even themselves. So template metaprogramming is just one metaprogramming technique where we use code templates. You've probably all used template metaprogramming in your development, maybe you just didn't know how it's called. So here is one sample of a template that we use in our development in Java and Evolution framework. In our everyday development, it's a template defined in Eclipse for the execution of select queries. So now we're going to talk about generators real shortly. So the definition of generator would be that it is a program that takes some kind of a specification and generates a piece of software from it. The generator takes the specification and it should check its validity. It should also warn the user if there is any kind of errors and warnings. It should use the default values. If not otherwise specified, it should perform some kind of optimizations, and of course at the end generate a concrete software implementation. So the development of generators is quite expensive, and it can also become quite complex. So when we build generators, if we have a complex case, we should modularize their design. That just means we implement a set of smaller generators that work together, and the base generator that connects them. In the second part, we're going to talk about aspect-oriented programming. The idea of aspect-oriented programming is to provide support in object-oriented languages for the definition of aspects. So our Currently, most commonly used object-oriented paradigm has a very good support for the definition of components, but it lacks support for the definition of aspects. So what's an aspect? An aspect is a common feature that is scattered across various classes and methods. Those features are also called cross-cutting concerns. The most basic examples are logging and checking for access rights. So imagine your piece of software, you probably have logging included in mostly every method or most every class in your software. So the aspect-oriented programming allows us to separate those kinds of aspects and place them into models, and that can be composed with all other components that we use. The Java's implementation of aspect-oriented programming is named AspectJ. AspectJ uses waivers that take instructions that we define in our aspects, and those instructions are named devices. The important term here is the join point. That is the place where the waiver will insert the aspect code. So AspectJ currently supports 11 types of join points. The most common are method call and method execution. So in your aspect you can define, for example, a point cut named onClick functions and match the execution of every function whose name ends with onClick, and it is inside of this package. You can also define a point cut named to calculate functions. You can match not the execution but the call of some function inside of some package. You can use wildcards, etc. Annotations become quite useful when working with AspectJ because they allow us to easily mark certain parts of code. When we define some kind of point cut, we can use an annotation. Here we can say that we want to match a function that has an annotation, doesn't have an annotation, has two annotations, one or the other, etc. AspectJ has one more pretty cool feature, that is that we can define custom errors and warnings. So we create an aspect and we can declare, for example, an error that the function name doCalculate in this package should be executed only in a class that has an annotation trusted code. If this is not the case, we will get this error. So here you can see how this error is displayed in Eclipse. So you see the error on the line where we try to execute this function and the class is an annotated trusted code. The difference between error and warning is in the colors, so warnings are marked yellow. AspectJ supports also a few kind of different devices. The most commonly used are before, after, and around. So we can define some code to be executed before some function. We can define some code executed after the function or around it. So both cases. We can use variables gets and sets. So here's an example how you can match every set of variable text in the class glabel_edit. We can use generics. In our definition of point cuts, we can use generic parameters, and we can also use a variable number of parameters. So how to get started with AspectJ? I've tested it in Eclipse, but it's also available for other IDEs. You'll need two jars, the AspectJ and the AspectJ runtime. You can use the AspectJ development tools. You download them from Eclipse using this link. You go to help, install the software, you put this link in, and download and install it. And if you want to use AspectJ on an existing project, you will need to convert it to an AspectJ project, and then you can start creating your first aspect. In the same way you create a Java class. You right-click on a package, a new aspect, and create your aspect. So that's it about AspectJ. Now we're going to show you how we developed our form generators. First of all, this is Evolution Framework. This is our visual editor where we draw our web forms. So on the left side we have a set of controls that we drag and drop on the form. And on the right side we have a set of properties. So every control in Evolution Framework has a set of properties. We drew the complete form, press the save button, and the Evolution Framework will generate the complete GUI for the form. And the event methods. For example, for a button we'll get the onClick event handler, we can override it and write the code for this complete form. We decided to implement some generators also to generate the Java part of the code. So why is that? We want to avoid repetitive tasks. In our everyday development, we see that we have a lot of forms that are basically the same, but written by several developers, the code is not exactly the same. We most commonly use a view form. We have some kind of a grid with different kind of data. We have some basic search, advanced search. We have some action buttons on the view form. We have the edit form with some different kind of input fields and some other action on the edit form. So as Mr. Manik said here, we programmers tend to spend a lot of time on tedious tasks, and we most certainly follow the same patterns. So if you compare code written by a few developers, you will most certainly see their programming pattern. So this is how we design our form generators. We want our users to use existing Evolution Framework features. Those are the DB Designer and DB Manager. DB Designer is used to design the database. We save the database design in XML format, and we use the DB Manager to actually create tables in the database and to create a DB record using our ORM. When the user has created a DB record, he goes to a configuration or feature selection screen. He chooses a set of features that he or she wants and presses the build button, and that's it. The complete form is generated: Java part, the GUI, complete Evolution Framework form. So how does it work? The configuration screen uses a page generator and, of course, some other utility classes. The page generator uses form-specific generators. Both the page generator and the form-specific generators use code templates. So in Evolution Framework we have two types of code templates. We use the XML templates, where we define a set of controls for the form. We use the control XML templates, and the Evolution Framework will generate HTML and the JavaScript from this XML. We use the Java code template simply to avoid code duplication in our generators. So I will show you in demonstration. Here we have a sample, real simple database with a single table named documents, just for the purpose of this demonstration. So as a user, we'll just run the configuration screen. And here we have a set of XML definitions for the database. We'll just choose this one, and the configuration screen will list the columns for this table. So we'll choose all the columns and say that we want to show them on the view screen. So here. And we'll also want to show all the columns on the edit screen. We'll say that we want to use all of the columns except the ID in advanced search. And we'll say that we want to use title, description, and a note in our base search. Here in our view screen configuration, we can say that we don't want to see an ID, we make it invisible. And on our edit screen, we can say that we want to make it disabled. We want to see it, but we want to use a change in our ID. So here are some additional features we can add to the view screen and to the edit screen. I'm just going to turn them on and show you later on the form. So those are the record files and the workflow tasks. Here we define just the package for our form, a title, class name, and the master column. We'll choose title. This is just a column to be used for linking between the view form and the edit form. So we press the generate button. We wait a little bit for our project to refresh. And here we have two new forms generated. I need to restart Tomcat. So when we wait for our project to build, I'm going to show you the generated code for the view form and the edit form. So here we have our forms, view form and the edit form. So for the view form, we have the onFormEntry function generated. That is the function called onFormCreate, and when we return from edit form to the view form, we have a function that will refresh data in the grid. We have the generated part of code used for filtering, searching. We have the generated part of code used for data sorting in grid. We have the part where we build and execute our query and where we fill our columns with data. Then we have some on-click handlers. We'll open the edit form when the new button is clicked. We'll also want to open the edit form but in edit mode when the master link is clicked. We have the delete button handler, we have the search button handler, and we want to also refresh the grid when the user presses enter. We have the pop-up link that will show us the advanced search options, and the clear button that will clear all of the input fields. Let's take a look at the edit form. The edit form uses two class variables. It uses onFormCreate, and it will fill the input fields in the edit mode from the record. We have the close button handler, delete button handler, save button handler. Here we will map our input fields back to the record and update or insert a new record. So That's the part of the generated code. So here is our view form running. So as you can see, I've inputted some data into this table before, so just for the demonstration. This is a master link. This is a fully functional evolution framework grid. So if I set 5 pages per row, I will get pagination working. I'll just return this to 25 rows per page. I can sort using any of the column in the grid. Here is the part where we use base search that we set, so I can search the title. For example, if I press enter, I find document number 9. Here is the part where we define our advanced search. So we have different input fields for each column. We can use searching the amount, for example, 350. We can clear all the fields. And we have the action buttons to add a new record or delete the record selected here. So we'll just open, for example, this record. Here we have some additional evolution framework features. We have record files. We can copy-paste files here. We can use scanning or simply upload new files. So those files will be connected to this record automatically. We also have workflows here. So we can define workflows for this table. This is just one real simple workflow task. So we have a single activity with one performer, and we connect this workflow to the documents table. So it will automatically appear here. We can define a work task for ourselves. For example, please do this activity. And we will get the task on this record. Here we can take a look at the task being executed on this record. So when I press done, this task is finished. When I close the form, you can also see record tasks and record files listed in the grid. So that's it. Let's just take a quick look at code behind all of this. So we have a base generator here that uses form-specific generators. We have an interface for those form-specific generators. Each form-specific generator should define its own imports, some class variables, an XML body and a Java body. So for example, we have a generator here for the view screen. The view screen generator defines its own imports here. It doesn't use any class variables. It generates a Java body and an XML body using code templates. So let's take a quick look at our code templates. So here's an XML template for our grid control. You can see it is quite simple. It uses the set of parameters for this template are defined on the first line. So if we take a look at the Java templates, our template for filling the grid in Java is this. And in the same way, we define parameters in XML templates. We also define parameters on the first line of the template for our Java templates. That's it about form generators. Let's just make a real quick demo of AspectJ just so you see that it actually works. Those lines of code that I showed you in PowerPoint. So we were going to define a few point cuts here and one error. Here we have a few advices. And we're going to go to our generated view form. And we're going to add a real simple function here named do calculate. So that's it. And here we have our error definition. So you can see the error in Eclipse. This is the error that we defined here. So untrusted code should not call the calculate method. So if we use this annotation on our view form, we add the annotation to the class. and we don't see an error anymore. So that is the definition of errors. Here we have a point card to define that will match every function ending on click, and a point card that will match every function name do calculate. And here we have the before advice. Before every on click function we will do something, put your code that you want to execute before every on click function, and here we have the code we want to execute after every on click function. Here we have a round advice around the do calculate function, but as you can see this advice has not been applied anywhere. So that's because we defined the do calculate function point cut as a call to the function, so we actually didn't call the function anywhere. So if we go back to our view form, we'll just call the function here. And you can see immediately that this function is advised by simple form aspect around advice. You also have a real nice view here from AspectJ, where you can see that this method has been advised here, and you can jump to the advice immediately. So here we'll execute some code before the calculation. We'll take the return value. We'll print the return value. Do something after the calculation. And that's it. We'll show you that this actually works in our Evolution framework. Here we have a few more advices just for the demonstration. This is advice for the set of every text property. So you can see that this has been advised in a number of classes and methods. So we'll run our view form again. And here we see that some code has been executed before the calculation. We took the return value from the function, and we also executed some code afterwards. So we'll also define the before and after advice around the onClick function. So if I press any of the buttons on my form, I will get the code executed before and after that click. So that's it from this demo. So if you want to find out more about this subject, here's a list of literature and references. And thank you for your attention. And if you have any questions, please.
I have a question. So when is the code generation actually happening? Is it hooked up to the Eclipse lifecycle, or is it on each story of the Tomcat, or is it actually?
When is code generated?
Yeah.
Well, the code is generated on Tomcat. We have our generators running on the same instance where our forms are generated.
Okay. And one more. So you added the annotation to the generated class. Which sections of the class can you also modify, and how is it making the difference? So for instance, if you add the static constants to your class, will it still pick it up and work?
I think it will work. You can try it out. Haven't really tested that part. Any more questions? Thank you.